Thanks, Chancho. Thanks for that. As you heard, the solution that was used previous was quite complicated. And PSO, Google PSO, we came to solve our customers' pain, to help them be more successful, because that's what we do. How do we do that? We built this natural language labeling tool. It allows the ability to prepare documents for AutoML API, increasing AutoML model accuracy, and that's really important, and allowing subject matter experts to quickly label and relabel free text, their patient visit reports, their different types of reports on processes. And a more important thing is you need a simple interface for the subject matter experts. And remember, the more labeled documents, the better their predictions are, at least in this specific use case. And one important thing is it needs to be multilingual. Roche was really highly interested in using AutoML to label some of their German documents, for example. So how does the flow work? How do they actually use this tool? So basically, the subject matter expert is a doctor or basically a non-technical person who is highly skilled in, say, the medical field, and they're able to identify different procedures and identify different problems and causes of procedures and things of that nature. So what they do is they begin by opening up the AutoML PSO labeling tool. We'll show that in a minute. I'll give a demo in a minute. And they have a bunch of documents that are loaded in the bucket. And these documents are loaded in the bucket by the tech team at Roche. So they decide, okay, we're going to label 5,000 documents. So they'll load them into the bucket, and then they'll give the SMEs access to the labeling tool. And so they go to labeling tool. The labeling tool requests a prediction from AutoML. The SME looks at the prediction and says, this prediction is good or this prediction is not good. And then the labeled document is saved into cloud storage. And then they continue that process as they label the documents until they have a batch of documents that are big enough that we can create a model with. And at that point, when we have a batch of documents that are big enough to create a model with, and we can stop it at any time, everything happens in real time, we can create a CSV and generate a new model, which can then be fed back into the process for labeling the same documents or relabeling brand new documents, but relabeling using the predictions from the previous batch. So the solution itself, it's a React.js front end, a Node.js back end. All configuration is stored in the bucket. We use Cloud Run or GKE. You can use a container optimized instance. Everything is persistent in real time. So if an SME steps away from their desk after clicking a button, everything is stored to the bucket. There's no databases. There's no sessions. Everything is real time and persistently stored. And additionally, we have the ability to do this secondary type of labeling using a hierarchical model. We'll talk about that when we get to the demo. But basically, as you can see in the solutions overview, it's a pretty straightforward web app, with one tier or two tier, I suppose. Not really a database in the back end, but we do use cloud storage to manage all the persistent data and configuration files and things. We have a lot of features in this that we built out. We have multilingual support, very important. Support for for unlimited size documents. That's important because your batch sizes can get very large. Configuration per user. You can have SMEs configured different ways, so they're doing different things. And we have this I'm feeling lucky mode, which was a funny request because they statistically need to label the documents in a kind of randomized fashion. So if they imagine they have 10,000 documents and they want to label them for a batch, they want to label 500. You don't want to label the first 10 or the last 10, kind of similar to hotspotting. They need a statistically random sampling of documents for their models. Again, we have some other features here, as you can see. It'll make a little more sense once I get into the demo, which I will do right now. So here's the AutoML Labeling Tool UI. Remember when the SME first gets, this is the first thing they see. when they first get to the application. Most of this stuff they'll have to configure the first time, so they need to configure their settings. All of these settings are stored, the user settings are stored as stored in the browser using browser local storage, so that gives per user setting. So if I'm a user A, I can have my settings, and user B, I can have my settings. You'll see that this particular interface has no authentication. That is by design. We do have a fork that does authentication, and additionally, you can put the IAP in front of this to give authorization protection for publicly exposed endpoints. So in the configuration, you can see we set the bucket name. The bucket name is where all of the files and configuration is stored, the project ID, and the location. In AutoML, models are regional, so they're stored in regional regions. So you need to define where those are stored. So the AutoML Labeling Tool knows where to pull your model when it's doing the prediction, and that just passes it as an API call to the backend. We'll see in a second. So next, you can see there's these hamburger icon on the upper left. This is kind of the main UI driver of this app. You can see we have the cloud storage bucket, and it tells you what bucket you're looking at. We have the generate CSV button here. We'll come back to that. The shuffle next, that's the I'm feeling lucky button. And all of the people who have remember Google a few years back, we had that button for going to the first random result. But this actually randomizes the selection of documents, so you get a random document. So let's just start off with the shuffle next I'm feeling lucky button. So you can see we loaded a document, and it's not labeled. Right, so let's imagine this is the very first time we're seeing documents and we don't have a model and we need to start labeling stuff. So we would go through and say, okay, what's the problem here? And we look and we find that potentially the problem was that there was some blood loss, so we'll mark that as a problem. And you'll see that potentially there was degenerative joint disease, that was a problem. And this rotator cuff was a problem. And then we scroll through, we can see potentially that this was the remediation. They tolerated well and they were transferred to the intensive care unit, so that was the remediation. And we can look at the cause, saying the cause could have been there was an oscillating saw that caused a head cut, and that was the cause of this. And that seems quite quite violent, but that was the cause. So then when that's all done, there's a JSON file that's associated with this, and every time I actually do a label I click here, that JSON file is being updated. So if we close this app right now, we still could generate a model from it. And let me just quickly go into cloud storage so you can see what it looks like. So if you look at cloud storage here, you can see we have the AutoML label test bucket that we had configured in the AutoML tool, and you can see all of the files here, and they are text files, and there's several thousand of them. Really quickly, I'm going to show you where the JSON files are. Remember, the JSON files are what we use to train the model. So if we look at annotations, we can see that there's a .jsonl file here. I think we just did 1673, so let's open that up. And let's just quickly look at it so we can just get an idea of what this JSON file looks like. If you've done any AutoML work, you are probably familiar with how these annotated files look, but let's just pull it up quickly. This is not the one that we had just labeled, but we can look at it anyways. As you notice, you'll see that we have the content here. Here goes the content. This is the actual text of the file that we look at. And then on each of these annotations, we have a text extraction and text segment, and it's basically just string offsets. And we say, okay, between offset 30 and between 5 and 20, it's a problem. And you can see we've labeled some problems. We've labeled remediation. We've actually even labeled this text summit label, and that text summit label is kind of showing you how that these labels are completely dynamic. So if I go over here to this button, configure labels, it'll let me modify the JSON that configures the labels for this bucket. So you can have a different bucket with completely different labels and different configuration and different files. And it's all controlled here. So what I can do is I can see that we have the text summit text here as a label. So what if we decided to, we said, oh, and we can see that text summit is misspelled as text summity. But let's change it to we'll change this label to the Google label, and we're going to use our Google green. I'm not so good at doing hex colors in my head. You would generally put a hex color here, but I know that there are some basic colors that apply that will work because HTML is good like that. So we'll use Google green. And I click apply to document, and what you'll see is immediately the text summity label changes to Google, and it changes to green. And now if I want to label one of these things as Google, I can label it as Google. And it's not just modifying, I can add an additional one in here. I can say, let's add an additional label. We will call it Google PSO, and we're going to make it yellow. And we apply that. Now you'll see we'll have an additional label here called Google PSO, and it's yellow, and we can use that now to actually create labels. So this is all good and well. There's other tools that do this and do it fairly well. But let's get to the place where this actually becomes really powerful, and let's Roche really harness the power of AutoML and multiply the power of AutoML by using the predictions. So there's two ways to set up the predictions. You can either go to configure labels, and there's a default model name in here, and that's going to give you a default model name. We won't do that. We'll manually select the model. So what we can do is you can go here, and you can see what you have. You have none and test model 1. So if we select test model 1, what you'll notice is you'll see an outline in a minute when it pulls the prediction. What it does is when I choose that, it's actually passing this entire document over to the AutoML prediction API and getting predictions back and then displaying them here. So now that we have the predictions back, we can do what's called relabeling. And this is where the power really comes into place. Is we can say, so for this particular document, for relabeling, we can say that AutoML thought that this word that we labeled as problem, it thought that it was cause at 47%. So the SME can look at this and say, well, who was right? Were we right, or was the model right? Or the prediction right? And then correct it as needed. So we can say, okay, we're going to correct that to cause, and we'll say this one is also, we can see it can be either remediation or problem. And if you look closely, what you'll notice is that there's an outline around the words, and each word has a prediction. When this document is sent to the AutoML API, it comes back with predictions. And so it has a prediction of a certain percentage for degenerative, a prediction for a certain percentage for joint, and a prediction for disease. And what the tool does is it goes and it averages those and allows you to see in one click what the predicted percent is for the entire sentence. So we could say for the entire sentence we thought it was 24% problem or 52% remediation. So by giving SMEs the ability to correct the model in real time, and that's actually not real time, to correct the model really accelerates and really gives AutoML, really unlocks the power of AutoML. AutoML is a great product. Unfortunately, without a little bit of tooling around it, it's not really able to be used by customers. And there are a lot of different tools out there. There are a lot of tools out there that can do this, but they're more complicated. They require the subject matter experts to know about labeling. And these are subject matter experts that are doctors, and they're not they don't care to learn AutoML or machine learning or labeling concepts, really. They just want to be able to click and say, this is one thing or this is another thing. And that's what this gives them the ability to do. And so imagine now we've gone and now we want to say, okay, let me do the next document. And I'm going to grab this one. I'm sorry, that keeps popping up. This is going to grab another document. And you can notice that this document has never been labeled, but you can see that there are predictions still here. So once you turn on the predictions, you basically get them for your as long as they're on. And you can, and again, we can see that this one was labeled and it was predicted at 8% problem, 12% cause, 7% remediation. The model wasn't very good at predicting this particular document. So what would happen with the SME would go in and label this document, relabel it, or as they call it, but make sure that the predictions match what is reality. And by doing that, we can create a new model. And that new model now, since it's been corrected on different data, is now more accurate. And that's really powerful. Now we're creating a more accurate model. And so we will relabel 50 documents, create another new model, and we can again use that model to further create additional predictions and further make the model even more accurate. So on every iteration, your model becomes more and more accurate. And with the way this tool works, the number of SMEs and the number of documents that you can do this with is really unlimited. You're not limited by the teams using scripts to modify documents that have been created elsewhere. It's very, very clean, very straightforward for them to do that. So let's talk real quick about word labeling mode. So that was the top label. Word labeling mode is a hierarchical model that they use, and it's really specific to Roche. And what happens is now we had labeled this guy right here, and we labeled it as a problem. Now Roche also needs to know more than just that this sentence was the problem. They need to be able to look in and be able to say which words within the sentence were the actual were particular parts of the problem. It's basically sub problems. So when you enable word labeling mode, what you get is you get the ability to label words that have been configured for labeling. Let me explain that a little more. So as you can see, if we turn off word labeling mode, this sentence has already been labeled as problem. Right, but when we turn on word labeling mode, you can see that that sentence that we labeled as problem, you can't label anything else but the problem sentences that were labeled in the regular mode. So now that we have labeled the sentence in word labeling, we can label it in word labeling mode. So we've labeled neurology as a generic problem. Additionally, we can say, oh, well, the specific problem was the generic problem was neurology clinic. The specific problem was Dr. Z, for example, right? And that allows them to have more accuracy on their side for when they're using these models to do predictions, to detect when the treatment of a patient diverges from what they expect the treatment to be. And they can so if you go in and break your leg, they want to be able to predict that the doctor is going to do the right thing after the fact and be able to compute on that. So that's the word labeling mode. Thank you very much, and thank you for your time. So word labeling mode. Word labeling mode is, as I said, a hierarchical mode. When you're using word labeling mode, the individual word is being labeled and not the entire sentence. And it's hierarchical because the individual word is related to how the parent sentence was labeled. So, for example, in this particular document, we can see we have estimated blood loss approximately 125 cc labeled as a problem. If I turn on word labeling mode, you'll see that first here at the top, the word labels, they change, and now you just see one word label called problem. And then it has these sublabels called generic and problem specific. And also in the main part of the document, you notice that you can't highlight anything except sentences that were previously labeled as problem. So, and when I mouse over, you can see that we're only highlighting a single sentence. So for this one, we can look at it, and maybe Roche would say the generic part of this problem was the blood loss. So we'll say blood loss was the generic part of the problem, but the specific part of the problem was the 125 cc's. So we'll say that was the specific part of the problem. And then we'll go and we'll do that for all word labels that we have defined, and follow the same process that we did for the parent labels. And we're able to create three separate or additional models based on the parent labels. So the interesting thing is that each of these word labels are related to the parent label. And so in order to configure the word labels, you go back into configure labels, as we did before, and you can now see, if you look, you see we have word labels. I'm sorry about that, word labels. And you can see where we define problem generic, problem specific, and this word label is an array that lives under the menu item of problem, which is a problem label. So we could add additional ones. Let's just go ahead and add an additional sublabel here. Having trouble here mousing, but bear with me. Gosh. And so if we go to cause and we add a sublabel under cause, we'll just do that. Pause. So we go into the configure labels button and we look at the document settings, and we can see that we have problem generic and then the problem specific as the parent label, as the text of the label, and problem specific as a text of the label, and these are sublabels of the parent label. And so let's go back to the generate CSV. The generate CSV is how we actually get this data into AutoML and actually complete that iteration we talked about. So if I click generate CSV, the back end goes and it gathers up all of the JSON files and creates a CSV that points to those JSON files that's ready to be loaded into AutoML. So the very first one at the top is the sentence label, the main model that we use, and then you can see that under word labels we have separate CSVs. So each CSV is separate, and the reason why these ones are in separate files is because the data that they refer to is specific to the label. So let me restate that. So this problem generic, when we look at the JSON for this label, we'll see that the content is not the entire document, but it is just the sentence of the parent label. So what we can do here, so let's go back to generate CSV. So we can just create a label, or we create a model. So we go and we copy this guy here, and we go over to the Cloud Console, and we would go to creating a new data set. We would use entity extraction. I should have given it a better name, but basically then you pass in, the AutoML sorry about that. Let me get back here. I need to get the CSV file because we're going to paste that guy right into AutoML. believe we're generating now. Is that what's happening? Let me click generate one more time. All right, and so we grab this, copy, we paste right here. This is AutoML format. We hit import, and if you're familiar with AutoML, you know that this will take about 4 hours minimum. So we won't be waiting through that. But what at the end of this, what you will get is a model with this name that will show up here that we can use to continue the training. And similarly with the word models, we'll get word models that we can train that will show up here as well. So that about covers it. Thank you very much and appreciate you for your time.